Magandang umaga, hapon, tanghali, gabi, kung anong oras nyo man ito pinapanood. Kami nga pala ang third group, and today we are going to be discussing about structural engineering as a specialization for civil engineering majors like us. And to start it off, here we have Miss Alexis C. Maaño to talk to us about the introduction to structural engineering. Please welcome her.
Good day, everyone. So today we're going to discuss about the structural engineering and its components. So, what is structural engineering? It is a core branch of civil engineering wherein the structural engineers are trained to understand, evaluate, and calculate the strength, stability, and rigidity of structures such as bridges, buildings, towers, marine structures, dams, tunnels, and other infrastructures by applying mathematics and physics on construction to assure that it is safe, useful, and economic. The specialization for structural engineering includes building and pipeline designing, mechanical structure, and analytics on the structure that is used to support the loads in the most economical way. The loads applied differ based on the nature, like the loads for spans because of traffics, impact of solid breezes on high structure, loads for structures in the light of changes in temperature due to climate change, and burden because of tremors. Now let's proceed to the history of structural engineering. All throughout the ancient past, structural engineering was known as an art rather than science. No record exists of any objective thought, either with respect to the quality of structural members and strength of basic materials. There is also no theory existed of structures, and understanding of how the structure stood up was extremely limited. The builders, which are mostly masons and artisans, were guided by the rules of the thumb and experiences, which is passed from generation to generation, protected by the organization and enhanced by the new knowledge. The recorded history in structural engineering started in the ancient Egypt in the 27th century BC. Imhotep, the first structural engineer known by name, constructed the first step pyramid in the Egypt in the 26th century BC. So yung tutukoy na step pyramid na kinonstruct ni Imhotep ay yung famous The Great Pyramid of Giza for Pharaoh Djoser, which is remained as the largest man-made structure and considered as unsurpassed until the 19th century throughout the ancient and medieval history. The ancient Romans made an interesting bounds in structural engineering which are still up until today, pioneering mason and concrete. So sa kanila nanggaling yung idea na yun. And they include aqueducts, thermae, lighthouses, columns, defensive walls, and harbors. And isa pa sa mga reason kung ba sila na-considered successful in terms of engineering ay dahil sa precise viewing methods nila which is based on dioptra, broma, and chorobates. 15th and 16th century, and regardless of lack of bar hypothesis and analytics, Leonardo da Vinci created many building plans that is based on logical perceptions and rigor, including a plan for a scaffold to traverse the Golden Horn. The foundation of modern engineering were laid in the 17th century by Robert Hooke, Galileo Galilei, and Isaac Newton with the distribution of three logical works. On 1638, Galileo Galilei published a book entitled Dialogues Relating to Two New Sciences, illustrating the studies of the quality of materials and the movements of articles. It is the primary foundation of logical way to deal with the structural engineering, including the main endeavor of building up a hypothesis for beams. It is also viewed as the start of a structural investigation, numerical representation, and planning of building designing. On 1676, the first statement of Robert Hooke's law provide a scientific understanding of the elasticity of materials and their behavior under loads. On 1687 rather, Isaac Newton published a book entitled Naturalis Principia Mathematica, setting out his law of motion and providing for the first time an understanding of the fundamental laws governing structures. In the 17th century, Sir Isaac Newton together with Gottfried Leibniz developed the fundamental theorems of calculus, providing one of the most important mathematical tools in engineering. The real advancement in the structural engineering was achieved in the 19th century during the modern insurgency when significant advancement was accomplished in the studies of structural analysis and material science. Now that we're done discussing the history of structural engineering, let's proceed to the role and importance of structural engineering. Structural engineers are responsible for assuring that materials utilized in the structure observe certain standard essential for general development. It means from the evaluation of the fortifying bars, the quality of cement and steel, rooftop types, beams, the amount of steel required, alignments prompting durability, and in general, to create an aesthetically pleasing structure. If you want to utilize complex plans and composite materials, it requires effective analysis. The focus is on plan dependability, security, quality, material particularity, and stress. That's why there are structural engineers that is acting as a sub-experts in architecture, which helps to depict inner and outside factors such as loads, wind, velocity, convergence, hubs, and landscape on basic steel frameworks and utilities. Structural engineers are required to study and identify the probability of occurrence of natural disaster in the location of a specific structure, which is helpful to assess the safety issues and to assess the capacity and durability of a structure to endure such situation. This is essential on planning the structure itself. The ideal factor of safety is given to quick, inclined spots contrasted with static spots. The firmest establishment would lose its capacity if the dirt-bearing limit can withstand the heaviness of the development. Legitimate flood control and water surface runways are predistinguished for tropical storm powerless spots. Same with dams and other hydroplant venture. Structural engineers work with other professionals such as geologists, traffic analysts, environmentalists, and geotechnical engineers. In other words, structural engineering is not complete in itself without the collective effort of other professionals. Aside from that, structural engineers promote efficient materials without trading off quality. They aim for capacity and safety without raising any pointless expenses. That's why structural engineers are important, because basic building affects life, safety, and merchandise of individuals, because of which additional carefulness is required during the development and review of the structures. So if you're planning to pursue structural engineering as your specialization, you should possess the following qualities. First is creative. Structural engineers use their skills and acquired information to configure and design structures that are rigid and adaptable to withstand pressure. Their information guarantees that structures don't twist and break down and put individuals' life in danger. Imagination is a key quality in making structures that are protected, functional, and effective. The next one is you should be a team player. So, structural engineers work close by a group of other development experts like architects, civil engineers, and other engineering specializations. These experts must cooperate and have cheerful relations from the earliest starting point of the task as far as possible. An incredible engineer ought to have the option to mix in the group to guarantee that the venture is effective and finished in time. You should also be a good problem solver, since there are different conditions that an engineer may run over throughout some random tasks or negative site conditions. Now and again, structural engineers are called upon to ensure that old structures can withstand powers that weren't placed into thought during their development. Qualified specialists ought to have the option to concoct snappy answers for these issues. Yes, may mga unexpected na nangyayari sa site, so dapat mabilis kang makaisip ng solution para dito. Since in constructing structures, hindi pinag-isipan yung solusyon na ibibigay mo since nakadepende dito yung safety ng mga tao. So, as an aspiring engineer, dapat pagtatrabaho ka, hindi mo lang iniisip yung sweldo na makukuha mo. You should also think na kaya ako nababaho dito ay dahil kailangan kong matuto ng bago na hindi ko pa alam dati. And some of the things that civil engineers should learn are designing structure models using computer to software, ensuring that health and safety regulations are adhered to, supervising projects and updating clients on the progress, and recommending the best materials to be used. Yung mahalaga yun. So, these tasks require an engineer to be knowledgeable not only in engineering but in other fields. A structural engineer should remain up-to-date on the new technology and research. Since yung technology natin parang ang bilis nang ma-develop, dapat hindi ka na pag-iiwanan since mahalaga yon in creating plans for structures. And lastly, you should be meticulous because even the smallest deficiency in the planning or development of a structure may cause it breakdown. So, sinabi ko nga kanina, yung safety ay isa sa mga factor na dapat na pina-point out ng structural engineer sa pag-construct ng structure. And an accomplished structural engineer should focus on details from large even to the tiniest one. Key considerations ought to be watched particularly in planning the system of a structure. So, yung mga qualities na sinabi ko ay ilan lamang sa mga kailangang meron ka para maging isang expert in the field of structural engineering.
Thank you for that, Miss Alexis C. Maaño. Now, next on our list, we have Mr. Shan Cameron Domdom to talk about the types of stresses and structures. And let's welcome him.
Next, we have the types of stresses. Before we tackle about the types of stresses, we should know what stress is. Stress in engineering is a quantity that describes the distribution of internal forces within a body as it responds to externally applied force. So first, we have tensile stress. Tensile means the material is under tension and that there are forces acting on it trying to stretch the material. So tensile stress is the elongation of the material when a stretching force is applied along with the axis of applied force. Next, we have compressive stress. When a material is experiencing a compressive stress, it is said to be under compression. Compressive stress is a force that causes a material to deform to occupy a smaller volume. These two types of stress, tension and compressive, are also called normal stress. Next, we have bending stress. Bending stress is a combination of compression and tension. Bending produces tension and compression inside a beam or a pole. The molecules on the top of the beam get squeezed together, while the molecules on the bottom of the beam get stretched out. So as we can see, at the top of the beam, compression is occurring, while in the bottom of the beam, tension is occurring. Lastly, shear stress. Shear stress make the particles of a material slide relative to each other and usually result in deformation. In simple terms, one part of the surface is pushed in one direction, while another part of the surface is pushed in the opposite direction. It is common in bolts, for example. Next, we have types of structures. First, we have frame. In the construction industry, the term frame typically refers to a rigid structure that supports a building or other built asset, such as a bridge, or tunnel, or parts of them. Next, we have shell. Shell or shell roofs are made from structural springs when the shell material is thin in section relative to the other dimension of the roof and undergoes relatively little deformation under load. Shell roofs can be flat, but are typically curved, assuming a cylindrical, dome, paraboloid, or ellipsoid shape. The Sydney Opera House roof are one of these examples. Lastly, we have membrane. Membranes may be used as structural components of tensile structures. A tensile structure is a structure that is stabilized by tension rather than compression.
Thank you, Mr. Domdom, for enlightening us about the types of stresses and structures. Now we will have Mr. Abraham L. Andaya with the knowledge about the different forms of structures. Let us listen to him.
The combination of structural elements and materials are called structural system, and a structural system may be composed of one or more of the four basic types of structures, namely trusses, cables and arcs, frames, and surface structures. First, the trusses. The truss is used for a structure with large span where the depth is not important. A truss consists of slender elements arranged in a triangular shape. A planar truss refers to a truss where all elements lie in the same plane, frequently used for bridges, while a space truss is composed of elements extending in three dimensions. Truss converts loads that causes bending into tension and compression forces. Thus, it uses fewer materials and it is composed of slender and long elements. Second, the cables and arcs. Cables are used to support long span where using of truss is not feasible and could lead to significant increase in cost and size of structure. Cables are used in bridges structures but only limited by their sag, weight, and method of anchorage. Arc carry loads and compressions and it should be rigid in order to maintain the rigidity and shapes of the structure. Arcs frequently used in bridges and dome roofs. Next are the frames. Frames are used in buildings composed of beams and columns. The beam and column may be connected using a pin or fixed connection. The loading will cause the frame to bend and the formation depends on the applied load and member properties. There are two types of frame structures, namely rigid frame and braced frame system. The rigid frame consists of linear elements like beam and columns without pin joints within the frame, while braced frame are composed of beams and columns that are pin connected with bracing to resist lateral loads. And lastly, the surface structures. The surface structure is made from materials with small depth compared to other dimensions. It can be a tent or inflated structures. It can be made from reinforced concrete taking the shape of a folded plate or a cylinder, and this structure will resist load through tension and compression with a little bending.
Now that you know about the different forms of structures, we will now be talking about the different types of loads to be discussed by Mr. Sanchez John Joseph. Mr. Sanchez, take it away.
Hey guys, in our previous discussion, we talked about the forms of structures. So in this section, we will further move into the basics of structural analysis. So we will learn about the different types of loads, on what are they and how they influence our structures. So here we talk about them one by one. So first, we will talk about loads. Loads is also a type of force, so the loads can be of the various kinds depending on what you are talking about.
So, based on nature of the load, if we classify the loads, the first load that we will tackle
Is the dead load.
now, let's assume that we got two walls over here. So this is our ground and we got this our first wall and we got the second wall over here. And above these walls, we have placed, let's say, concrete slab like this. So you can see that this concrete has got its own weight that acts downward due to gravity. So the load of this concrete slab is known as the dead load. The self-weight of this concrete
Is the dead load. Dead loads also include roofs, floors, beams, and superstructures. In other words, dead loads are fixed structures.
So next thing that we're going to tackle is
The live load. So live loads are the temporary loads
that act on the structural member that we are going to build. So let's say that now you are standing on this concrete slab. So in this case, you become
the live load.
the weight of this structure or the dead loads acting downward, also the weight is also acting downward, which is
The live loads. Live load isn't actually only referring to a living thing. It also includes furniture or equipment, the chairs, desks, etc. To better understand, live loads are loads that may move and change its mass. The third load is about the wind load. The wind doesn't seem to be troubling you while you're walking, and the wind is blowing, so it might not exert a lot of force on you, but on a high-rise, huge building with large surface area like this.
so here's the ground and our building. Let's say it is 40 meters tall with an surface area.
So, in the windy seasons, the force due to the wind acting horizontally on this building might be high, so you need to consider the wind load as well if you are going to build a building. Wind load is simply the load due to the wind, which you will also take into considerations. The next or the fourth load is the earthquake load. The load due to the earthquake is known as the earthquake load, and it is very important to determine the earthquake load accurately in order to build a structure. So we know that the dead load and live load is acting on vertical direction due to gravity. The wind load and earthquake load, however, act in horizontal direction. So you can see that when the ground vibrates like this, so when the ground shakes, the earthquake load is induced. So when we're going to build a structure on a windy areas like near coast, we must consider the effects of wind loads to it, and also the earthquake loads commonly on areas near fault lines. Similarly, we got other loads as well as other are the thermal loads, also known as temperature load. It is simply due to the variation of the temperature, which affects the weight of materials used in the building on a certain temperature. Also, the last type of load, we got the vibration loads or the dynamic loads. It is the induced vibration in the building made by moving loads. Suppose that this building is near the highway where heavy vehicles run. It may be also due to impact loads and loads due to cycling machinery. So these are the 6 major classifications based on the nature of the loads. We have dead load, live load, wind load, earthquake load, thermal load, and the vibration load.
On to the fifth topic we go, where we will be talking about the common problems encountered by structural engineers, to be discussed by yours truly, Gerome D. Okay, so now we're going to be talking about the common problems and concerns that occur if you are a structural engineer. Of course, if you're an engineer, you can't expect everything to just go smoothly. Kailangan lagi kang prepared and on-site in case na may bigla ang problema na mag-occur. Of course, may mga problems even before the construction. And there are also times na di may iwasan na biglang magka-problema while ongoing yung construction. And at those times, syempre, katulad ng sinabi ni Ate Alexis kanina, as a structural engineer, you should always be prepared and mabilis mag-solve para maayos agad yung problem. Okay, so first on our list in the problems is the lack of accuracy. Okay, so lack of accuracy means, well, it's pretty self-explanatory as this name states. It simply means one of two things. Either hindi nasunod ng maayos si blueprint or possible din naman na si blueprint mismo yung may mali or may kulang information. Then napansin lang yung mistake during or while the construction is ongoing. Kaya nga hindi mahirap sundin dahil yun na nga, may mali or posibleng may kulang na information sa blueprint. Remember, failing to plan is planning to fail. Kaya anong solution sa gandang problema? Well, quite obviously, need natin i-secure na maayos yung blueprint. Double check or even triple check bago natin i-implement yung blueprint into the ongoing construction. Siyempre, hindi lang naman ikaw mag-check yan. I-check pa yan ni contractor, ni architect, na iba pang engineers na kasama mo on the site. Pero still, of course, bago mo ipakita sa kanila, dapat triple check and double check and quadruple check and kung ilang check man yan, sure ka na tama yung ipapasa mong blueprint sa kanila. Tapos, if may special or unique situations na alam mo may encounter whilst the construction is ongoing, syempre dapat maglalagay ka ng special notations or ng special notes para kay contractor para kung sakaling may ma-encounter man na problema while ongoing yung construction. Next problem on our list is the concerns with constructability. This occurs pag yung aesthetically pleasing nga yung design, say, ng isang architect, pero mahirap naman backupan ng functional design yung aesthetics na ginawa ni architect. Kasi di ba para sa yung magandang building or magandang makabagong design, if mahirap naman implementan and bigyan ng isang functionally and structurally stable na blueprint. There was even a meme going around sa internet, di ba? It goes like this, di ba? An architect's dream is an engineer's nightmare. The reason kung bakit nasabi yon ng mga ibang nasa internet is I'm going to be flashing some example pictures of those memes sa internet. So, ito, first example. And ito, another example. So, there are times na kailangan natin hindi pala there are times. We always must go with functionality first bago yung aesthetics. Kumbaga, huwag kang tiis ganda. Unahin mo yung kung saan ka komportable at kung ano yung gumagana. Paano mo malalaman kung ano yung gumagana? Siyempre, tulad ng sinasabi sa ibang commercials, doon tayo susubok na. Okay? Doon tayo susubok na. Kasi, they are tested for a reason. It has been researched ever since the history of time, tulad ng sinabi ni Ate Alexis kanina, na it has been through decades or even centuries of mathematics and research para malaman kung ano yung pinaka-functionally, pinaka-structurally integrous, may ganun mo word, may structural integrity, kumbaga, na design. Tapos, syempre, hindi naman yan basta-basta mag-go pagka umokay yung isa lang. Lahat kayo kailangan mag-go yan. Kailangan mag-okay si contractor, si architect, si electrical engineer, si structural engineer. Lahat kayo kailangan mag-okay bago mag-ongoing. And with that comes our third problem, which is communication gap. Communication gap is, once again, of course, self-explanatory. Communication, meaning communication or usap. Gap, meaning kulang or basta failure to communicate. An example for that is, di ba sa arts, may mga abstract drawings na open for subjective interpretation. Doon, pwedeng iba yung interpretation ko sa interpretation nyo. However, the same cannot be said for engineering. Kasi engineering is an objective profession. Hindi tayo pwedeng mag-subjective na kung yung 12 meters sa akin, dapat sa'yo 12 meters din. Kung 10 meters para sa akin, dapat sa'yo 10 meters din. Kasi, sabihin natin, if 12 meters yung nakalagay sa blueprint ko, tapos 10 meters yung nabasa ni contractor, syempre, hindi yan gagana kasi magkakaroon ng misfit na piece kumbaga dun sa frame. And ano mangyayari? Hindi magiging structurally stable si building. Kaya dapat laging clear yung communications sa engineering. Hindi lang communications as in salita dito, salita doon. Kailangan clear yung communications tulad nga ng sinabi ko, pati sa mga drawings. Kailangan yung blueprints kanina, sinabi ko na dapat properly labeled para pare-parehas ng intindi kung sino man yung magbabasa. Tapos, other than those, hindi lang naman si contractor, hindi lang naman si architect, hindi lang naman yung mga engineer yung mag-uusap-usap. Kailangan, ini-inform nyo din si client. You need to be informing the client about what is ongoing, what is going on, kung paano nangyayari yung construction, kung ano na yung current process, without using yung mga jargons. Kailangan natin ma-explain sa client natin na possibly hindi naman related sa mga terms or kung ano mang terms na specific para sa ating profession, which is engineering. So, kailangan mapaalam natin kay client kung ano nangyayari without using such jargons. Last on our list is material failure. So, material failure means, well, another pretty self-explanatory term. Material failure is when materials fail or kung sadyang lampas yung load-carrying capacity na in-apply mo para sa isang load-carrying threshold ng isang material. So, for this scenario, I listed 5 modes of failure, which are the overload failure, the buckling failure, the creep failure, the fatigue failure, and the wear failure. I think madami pang ibang modes of failure, pero yung 5 yun muna yung discuss ko for this specific lesson. First, failure, overload failure. Ano yung overload failure? Well, quite, hindi ko alam, pang-encounter kung ilang beses ko na sinabi, pero self-explanatory ulit. Overload simply means overload. Masyadong madaming load ang in-apply para kay material. Lumampas yung stress na in-apply kay material kaysa sa stress threshold or sa stress capacity na kaya niyang i-handle. Possible na mangyari to if na-miscalculate natin yung capacity ni material, kung na-overestimate natin yung capacity ni material. For example, akala natin kaya niya carry ng 50 tons, pero ang kaya niya lang pala is 25, kaya niya lang pala is 40 tons, then in-applyan nga natin ng 50 tons, and bigla siyang nasira. Well, hindi naman yun nangyari since meron din namang parang mga safety margins na parang binibigyan natin ng extra na carrying capacity si material para if ever na lumampas man sa threshold na dapat naka-assign sa kanya yung maging dala niya, kaya niya pa rin mag-go on. Pero yun nga, pagka nagkaroon ng miscalculation, syempre, bawal yun. Since engineer tayo, dapat as much as possible, hindi pala as much as possible, it is our duty as professionals na to make sure na yung gagawin natin is very, very sturdy and stable and strong. Next problem on our list is the buckling failure. Ano si buckling failure? Si buckling failure ay nagre-refer sa compressive stress na bigla ang naging bending stress. For example, meron ako ditong meron akong hanger. For example, ito si hanger. For example, sabihin natin isa tong post. Tapos sabihin natin si kamay ko, kamay lang, hindi kasama yung braso ko. Yung kamay ko is sabihin natin weight siya, sabihin natin roof siya. Itong roof ay papatong sa post. Pagka nasa gitna siya, 'di ba? Supposedly pababa lang siya. Mangyari lang sa kanya is compressive stress. Pero in the case, hindi naman nasa gitna nakapatong si post pagka roof, 'di ba? Nasa gilid siya. So, kung sabihin natin masyadong mahina yung material, tapos sumobra yung compressive force, sabihin natin sa kanan na to. Tapos, yung compressive force na yon, sabihin natin nag-compress dito. Tapos, matutulak to. Ito naman, magiging tensile force. Mangyayari sa kanya is magiging bending force siya. Katulad ng sinabi ni Mr. Domdom kanina, bending force is the combination of compressive and tensile stress. So, kung maging paganto man, tapos sabihin natin, hindi nakagitna si roof, or kung ano mang load yun nasa taas, tendency, hindi pa baba, hindi siya mako-compress. Ang mangyayari sa kanya, magiging bending stress siya. Ang mangyayari, mabibend siya. Bending stress. So, yun yung example ng ating buckling failure. Next failure is the creep failure. Ano si creep failure? Si creep failure ay nag-occur even with normal loads. For example, ang capacity man ng isang, ano bang pwedeng example? Basta sabihin natin, ang capacity ni calculator, sabihin natin, nakapako to dito. Kaya niya magdala ng, sabihin natin 10 kilos. 10 kilos kaya niyang dalhin. Kahit magpatong ako dito ng 5 kilos lang, over time daw, mag-fail pa rin siya. Ang cause ng failure na yon is simply yung exposure niya sa time and yung temperature. So, Ang meron sa mode na yun, nagsasabi yung mode na yun na pag mas mataas yung temperature, the higher the temperature, the lower the time that it can handle. So, mostly gumagana yun para sa mga bakal since pagka bakal, nag-expand pag mas mainit, tapos nagko-compress pag mas malamig. Tapos, pag nag-expand yung bakal na yun, parang mas madali siya ma-deform. Tapos, that equates to a lower holding time para mag-fail siya. Kumbaga, the higher the temperature, the faster the durability goes down. Mas mabilis siyang nagde-decay. Tapos, pag mas mataas naman yung temperature, vice versa, mas matagal yung parang lifespan para mag-fail yung metal na yun. Next on our list is the fatigue failure. Ano si fatigue failure? Si fatigue failure is the same kay creep failure na nag-occur even if hindi overloaded or hindi lampas sa carrying capacity yung ipatong mo. For example, ito si shelf, tapos may libro sa kanya. Wait. Okay, so kunyari libro si pizza box. It simply states na pag may pinapatong ka sa shelf or sa kung ano man yung pinapatungan mo, tapos tatanggalin mo, tapos pinapatong ulit, tatanggalin mo. After number ng kung ilang beses mo man ipatong at ibalik at ipatong at ibalik, or ang tawag natin doon is cyclic loading, at some point, magfa-fail si material na because of fatigue failure. Magagaya din natin siya kung paano nakuha yung term. Magandang basis kung paano nakuha yung term is for example, pag nagba-bicep curls tayo. For example, bicep curls. For example, may dumbbell. Pwedeng gamitin dumbbell. Example, dumbbell tong tape holder na to. Ang fatigue failure states na the heavier the load, the less repetitions needed para mag-fail yung material. So for example, 5 kilograms lang to si tape. Example lang hindi siya 5 kilograms talaga. Example, 5 kilograms to si tape. Sabihin natin, nakaka-50 repetitions ako ng curls. Sabihin natin, bumigat siya, naging 10 kilograms siya, magiging 25 repetitions na kaya kong curls. Tapos bumigat ulit siya, sabihin natin 20 kilograms na siya. Kaya ko na lang na reps nun is parang 12 or so. So yun, kanina, bumababa yung time niya with respect to temperature. This time, bumababa yung cycles niya with respect to weight. So, pag mas mabigat, mas madali mag-fail. Pag mas magaan, mas matagal mag-fail, syempre. Katulad nga nung bicep curls, which is applicable din naman sa real life, pag mas mabigat, mas mabilis mag-fatigue yung muscles. And last failure on our list is the wear failure. Wear failure is yung slowly na pagbawas kay material. For example, may two types ng wear failures. Si chemical saka si mechanical. Si chemical, halata naman, nababawasan ng material dahil sa chemical reactions. Mechanical occurs naman dahil sa mechanical, dahil sa physics, dahil sa kung ano mang physical interaction between two materials. For example, na magagamit natin dun is, sa mechanical may necessary. Sabihin natin ang necessary is si brakes. So si brakes, ang pinaka main job niya is to transform speed, yung energy mo, yung momentum mo mula sa speed into friction. Yung friction ng brake pads tatama sa brake disc para mag-slow down ka. So, ang nangyayari doon, napupudpud si brake pads. So, ang nangyayari sa kanya is nawe-wear siya. Tawag doon is necessary wear. Then, another one is unnecessary wear, which is yung wear na hindi kailangan. An example nun is, sabihin natin sa gears. Yung gears, they always collide with each other. Kasi ganun yung pinakatrabaho nila. Magtulungan. Pag gumagalaw yung isa, tatama sa isa, gagalaw yung isa. So, habang tumatama sila sa isa't isa, alam natin na slowly but surely, natatanggalan sila ng materials. And last example natin for wear is sa chemicals. Chemical wear occurs pagka may chemical reaction na nangyayari. Ang pinakamadaling example na maisip dito is 4K bakal, Fe, iron, metal, iron, ferrous. Pag kasi ferrous na tatamaan ng, sabihin natin, tubig or kahit oxygen, sabihin natin nagkakaroon ng chemical reaction. Si Fe natatanggal slowly, sumasama kay oxygen, nagiging Fe2O3 or nagiging ferric oxyhydride or mas kilala natin sa tawag na kalawang. So, ang mangyayari doon, si Fe2O3 is nababawas sa mismong buong Fe2 na piece. Yun natin, for example, ito, Fe2O3. Tapos, ito, oxygen to. Umalo to sa oxygen. Ngunit siya. Ito sabihin natin si Fe2. Tapos yung daliri ko si O3. So, nabawasan ng material si Fe. Example lang. Hindi naman siya. So, those are the examples ng failure. Material failure is the fourth problem na structural engineers encounter. And so, yun. Those are the common problems that structural engineers encounter. And I hope may natutunan kayo sa akin. So, yun. Kung nandito pa rin kayo, then great job! Natapos niyo yung presentation na hinanda namin for structural engineering. Sana may natutunan kayong bago sa amin. And sana hindi kayo nantok sa presentation na hinanda namin. Once again, we are the third group comprised by Mr. Andaya L, Mr. Domdom Cameron, Ms. Maaño Alexis C, Mr. Sanchez John Joseph A, and yours truly, Gerome D. Third group, out.